Okay, so in this video we will find the voltage across this capacitor. We will find the equation of this voltage by using these three lines of MATLAB code, and you can see the equation is over here. So let's see how to do this thing. So first of all, we have to make a differential equation of this circuit. So let's see. So first of all, let's observe this DC source. So if I draw a Vs versus time graph, I will see that at the time t is equal to 0 minus, that means the time is close to 0 but less than 0, the Bs was is equal to 0. But when the time is 0 plus, that means close to 0 but greater than 0, we have applied a DC source here. The voltage of the source is equal to VDC, and you see this graph looks like a step function ut, and the weight of that u is equal to VDC. So we can write this Vs is equal to VDC ut. Well, now let's see the current across this capacitor. So the current across this capacitor, I is equal to C dV by dt. This V is the voltage across this capacitor. Now if you observe this current is also flowing through resistor. If I assume that this is the ground, then this point's voltage is Vs and this point's voltage is V. So the current through this resistor is simply is equal to Vs minus V divided by R, Ohm's law, right? Then C dV by dt. Well, so now if I rearrange this equation, I will get dV by dt plus 1 by RC V is equal to Vs divided by RC. Well, so now what I will do, I will convert this equation, I will transform this, I will apply a Laplace transform of this differential equation. So let's see how to do this. So first of all, let's observe here. So this is Vs divided by RC. So Vs can be written as VDC ut divided by RC. So if we transform this, we will get, these are constant, VDC divided by RC, these are constant, so write as it is, and then write this ut. So if we transform this u, we will get 1 by s. So let's write Vs by RC is equal to VDC divided by RC 1 by s. Well, so now let's see how to transform dV by dt. So if I write dV by dt, we have a formula here that how to transform this differential. First we have to write s, then the Laplace transform of V, that is capital V, then we have to minus the voltage in time domain at 0 minus, that means this is the initial voltage of the capacitor, that means we have to minus this initial voltage. So let's assume that this V minus is equal to actually V initial. In our code we have write this V0 minus as V initial, then as V. So let's write this thing here as B minus V initial. Okay, then this is easy, 1 by RC into V, this is equal to 1 by RC, then the Laplace transform of V. Well, so now we have to rearrange this equation. So when we have to find V, so let's see how to do this. First let's write this thing VDC divided by RC 1 by s, and then let's take this thing at the right hand side and we will get V in positive V initial here, and then take this V common here and take s and 1 by RC here, then we will get s plus 1 by RC. Well, so this is actually the equation for V, and you see that this is in S domain, right? That means this is in S domain, but we have to convert it into time domain, and this thing will be done by the MATLAB code. So this part, transformation of transforming this into time domain, this part will be done by the MATLAB code. So see, we have write sims. So we have defined, these are the symbols, these are not variables, these are just symbols. And then we have made this equation here. You can see this equation is same to this. And then we have applied a inverse Laplace function here. So we are doing, this is an S domain, and to convert it into T domain we have to apply inverse Laplace transform, and this part will be done by this built-in MATLAB function. And if I run this code, you will see that this is the equation of the capacitor. So if I write this equation here, you can see V is equal to VDC minus e to the power minus t by RC, then VDC minus V initial. Okay, so now let rearrange this equation. So we can write, if I take a minus common here, we will get V initial minus VDC, and then e to the power minus t by RC. This RC can be written as tau, the time constant tau, right? So this is the equation for the capacitor, and by this equation you can simply find the equation of the current, because I is equal to C dV by dt. And you can also find the voltage across this resistor. Let's say this is the voltage across the resistor, and which is simply is equal to this. So by finding the voltage across the capacitor, you can find whatever you want. Okay, so thank you.